What's up, TUMNAD lectures? In this video, we are looking at what we call the protection mechanism by the stomach. If you find it helpful at the end of it all, please make sure you like the video, comment down in the comment section, and then subscribe. Let's go ahead and get started. So now we are going to be following these kind of objectives. So look at what we call the overview of the stomach protection mechanisms. Look at the cells that are responsible for producing a protective layer. We look at what we call the barrier makeup, and even also shall go little bit on what we call the clinical correlation. Okay. Now, in the previous videos, we have been talking about the gastric secretions. In this video, we want to see how some of these gastric secretions that are too corrosive, how is the stomach protected from being damaged by such kind of the gastric secretions. That's our main target of today's video. Okay. Now, first thing first, we need to first understand the stomach is always full of what we call hydrochloric acid and other corrosive substances like the pepsin, but they don't damage the stomach. So now we want to answer this kind of the question: how does the stomach protect itself from being damaged by what we call the dangerous hydrochloric acid? Because the hydrochloric acid in the stomach is 100,000 times super concentrated than the own blood which is going to be on the stomach. But how does the stomach protect itself from this dangerous hydrochloric acid? Now, this stomach is going to be lined by this kind of this thick kind of this barrier. It's going to be coating all around the stomach lining. You know how this kind of this barrier is called? This kind of this barrier here is what we call gastric mucosal barrier. Now, it is this barrier which is going to be protecting the stomach from being corroded by dangerous hydrochloric acid and even also what we call pepsin. Now, we need to first understand what are some of those components that make what we call the gastric mucosal barrier, because it's going to be having multiple of the layers that make up this kind of the barrier. Let's go ahead and see some of the components that make up this gastric mucosal barrier. Now, when you see critically this barrier, it's going to be having two kind of these important layers. We have this kind of this layer which is going to be on top, the one which is a bit black, and then we have the one which is going to be at the bottom, which is going to be just next to what we call the epithelial cells. Now, this kind of the cell, this kind of the layer which is just on top, that is always in contact with what we call hydrochloric acid and other kind of the gastric content, this kind of this layer is what we call the mucus gel layer. Okay? Now, this kind of the mucus gel layer is going to be composed of the following molecules. It's going to be having super concentrated of what we call the glycoprotein mucin, which makes it become more and more thick. So now this kind of the component is going to be having what we call a glycoprotein, which we call the mucin. Okay, it's also going to be having what we call water, and even also going to be containing what we call some molecules like what we call the phospholipids. These molecules, they make this mucus gel layer to become super thick in a way that there is not any kind of the hydrochloric acid that can pass through this mucus gel layer to reach this kind of the second layer which I'm about to talk about. Okay? Now, as you go deep towards the epithelial lining, we are going to be having another kind of this layer which is a bit blue. You know how this layer is called? This layer which is in blue is what we call the bicarbonate layer. Okay, it is called bicarbonate layer just simply because it's going to be containing high levels of what we call the bicarbonate ions. Okay, so now how this mucus gel layer and the bicarbonate layer, how are they working hand in hand to protect the stomach from dangerous hydrochloric acid? Now, if inside here we are going to be having, for example, we're going to be having this one as the hydrochloric acid. We are also going to be having what we call the pepsin. Okay. Now, these things are super dangerous. But we want to see if this pepsin wants to come and then passes through, maybe by some chance, if it passes through this kind of the mucus gel layer and it comes on this kind of this layer which we are calling the bicarbonate layer, guess what's going to be happening? If it comes over down here, this kind of the pepsin, okay, this kind of the pepsin, if it passes through what we call the mucus gel layer and it comes over on this kind of the bicarbonate layer, what happens on what we call the pepsin? Pepsin is going to be now getting converted into what we call pepsinogen. Okay, so now in other words, once the pepsin comes over and passes through what we call the mucus gel layer and reaches on what we call the bicarbonate layer, pepsin is going to get converted to what we call pepsinogen. Okay, and then what happens is that this kind of the acid, if some chance and it peruses through and then it enters and then reaches inside this kind of another layer which you're calling the bicarbonate. Remember, bicarbonate layer is one which is going to be next on what we call the epithelial cells. In other words, the epithelial cells are going to be having what we call more alkaline, more neutral pH because of the influence of what we call the bicarbonate. Now, if some acid bypasses the mucus gel layer and reaches the bicarbonate layer, what's going to be happening? We are going to be seeing that these kind of the acids, these protons are going to be reacting with what we call the bicarbonate, leading to the formation of what we call the carbonic, what we call the carbonic acid, of which this carbonic acid can quickly break into two kind of the molecules. The first one is what we call the carbon dioxide, and then the second one is what we call the water. So now this carbon dioxide is some of the carbon dioxide which we exhale during ventilation, and of course this kind of the water is going to be aiding in the lubrication in the movement of different substances within the GIT. So by doing that, hydrochloric acid will be neutralized whenever it comes in contact with what we call the bicarbonate layer. Such a beautiful thing. So now the question is, who is going to be producing the substances that make what we call the gastric mucosal barrier? We have this beautiful cell. These beautiful cells are what we call the mucus, cells. These cells, they are going to be producing all the substances that make up what we call the gastric mucosal barrier. And the example of these cells, we have the first one which we call the mucus, the mucus neck cell, and then also what we call the surface, mucus, the surface mucus cells. So now these are the cells that are going to be producing all the contents that make what we call the gastric mucosal barrier. Okay, it makes a lot of sense. So now, having seen all that, let's look at what we call the clinical correlation on what we call the stomach protection mechanism. What happens if this kind of the gastric mucosal barrier is damaged? Okay, that's what we want to look at in this time. Okay, now this kind of the gastric mucosal barrier, what are some of those substances that can damage this kind of the barrier? And once this barrier is damaged, it means the gastric lining is going to be now corroded by the hydrochloric acid and other substances. So now, what are the causes? What can cause damage? What can cause damage to call gastric, what you call gastric mucosal barrier? Okay, because it's something which is super very important. The first one which I want to pay much attention is what we call the drugs. Okay, what we call the drugs. And the classic example of this is going to be what we call the non-steroidal anti-inflammatory drugs. And the classic example in these drugs, we are going to be having a couple of them. We have, like for example, ibuprofen, diclofenac, aceclofenac, acetacoxib. What happened is that these drugs, they are going to be reducing the levels of the prostaglandins. Now, if they reduce the levels of the prostaglandins, you remember they inhibit an enzyme called cyclooxygenases. We have cyclooxygenases 1 and then also cyclooxygenases 2. Now, what happens is that some of these drugs like ibuprofen, they are going to be non-selective. They block all COX-1 and then COX-2. However, we also have some other drugs which are selective, like celecoxib, which inhibits only what we call the COX-2. What happens is that when you block that enzyme, you're going to be reducing the levels of formation of prostaglandins from a molecule which we call arachidonic acid. Because for formation of prostaglandins, we need to break arachidonic acid by the influence of this enzyme COX-1 and COX-2 from what we call prostaglandins. Meaning that these acids, they are going to be reducing the levels of what we call prostaglandins. Okay, so now when you reduce prostaglandins, it is these prostaglandins that comes over and stimulates these mucus cells to produce a lot of the bicarbonate, to produce a lot of the mucus that makes this gastric mucosal barrier to become super thick and highly concentrated is what we call the bicarbonate, which will aid in what we call the protection of the stomach from being corroded by the hydrochloric acid. Besides that, this kind of prostaglandins, they exert an inhibitory effect, what we call the parietal cell. Okay, they inhibit the parietal cell from producing hydrochloric acid. So now, If you have low levels of the prostaglandin, it means the parietal cells are not going to be inhibited from producing hydrochloric acid. They will instead increase in the production of what we call hydrochloric acid. By doing that, these kind of the acids, they are going to be predisposing someone to what we call gastritis. Okay, they are going to be predisposing someone to what we call gastritis, which some other people may call what we call the ulcers. Okay, and that explains why NSAIDs are prone to what we call formation of ulcers. Such another beautiful things. Okay, and then another one which is super very important that can damage the gastric mucosal barrier are the infections. And the main infection here is going to be what we call what we call the Helicobacter pylori, which we call the what we call the H. pylori. This Helicobacter pylori is also one of the most important kind of the infection that can damage this kind of the gastric mucosal barrier, leading to the exposure of the gastric lining, which can also be finally be affected by what we call the dangerous hydrochloric acid and even also what we call the pepsin. And then another kind of the substance that can damage this kind of the barrier is what we call alcohol. Okay, is what we call alcohol. So alcohol can also damage the gastric mucosal barrier. Even also what we call people who are doing more of what we call people who are the smokers. The smoke is going to be having a lot of the chemicals that can also irritate the gastric mucosal barrier, of which it will lead into exposure of the gastric lining, leading into what we call the ulcer formation. Okay, such another beautiful thing. So now that briefly covers the stomach protection mechanisms. If you find this video has been helpful to you, you have benefited, please, you can support me. And that one can be done by a couple of means. Hit the like button, comment down in the comment section, and then subscribe. Thank you very much for watching TUMNAD as always. Until we meet next time.